Let's take a look at evaluating exponential functions. Here we're given a function, f of x equals 150 times 1.35 to the x. 150 times 1.35 raised to the x. You've evaluated functions before where we take the value of x and replace it with a number, say for instance, negative 10, and then calculate the result that follows. But before you've done exponential functions, you've never taken that input value and put it up in an exponent before. This is a straightforward calculation in your calculator. So you can type 150 times parenthesis 1.35 parenthesis caret negative 10 and then close the parenthesis. So this part right here will keep everything up in the exponent for you by taking that caret, exponentiating it, and then wrapping up what's in the exponent in parentheses. So you should come up with that value f of negative 10 is approximately 7.460253311. That's just where my calculator stops. Of course, that decimal continues going. We want to round it somewhere appropriate. If your homework question gives you a particular place to round, then that's what we would do. And we would say that f of negative 10 is equal to then 7.46 rounded to 2 decimal places. Let's try another one. Let's evaluate f of negative 5. So again, taking the original function, f of x, we're going to evaluate x when x is negative 5 and calculate the function value that outputs. So f of negative 5 will output 150 times 1.35 raised to the negative 5. And we'll get in the calculator approximately 33.45 rounded to 2 decimal places. So just to recap, when we're evaluating, we're popping in a particular value of the input and discovering what output is associated with it on this function. So we see that given that f of negative 10 is 7.46, we have the point negative 10, 7.46 on the graph. Given that f of negative 5 is 33.45, that gives us the point negative 5 and approximately 33.45 on the graph of this function. Let's continue on. Evaluating f of 0. So I will pop in a 0 for my x and evaluate the outcome raised to the 0. I don't need a calculator for this one because I recall that anything raised to the 0 is 1. So f of 0 is going to output 150 times 1, or just 150. That gives us the point 0, 150 on the graph of this function. And then we can evaluate f of 5 and f of 10. f of 5 will give us 150 times 1.35 raised to the 5. That gives us 672.61. It's 605. I'm going to round to 2 decimal places. And then f of 10. We're going to have 150 times 1.35 raised to the 10. Be careful there. It's not just 1.35 raised to the 10. It's certainly not just 13.5. We're not just moving the decimal. We're multiplying 1.35, using it as a factor 10 times. 150 times 1.35 raised to the 10 is going to give us 3,015.98338. So let's take a look at what this graph is doing. We have an initial value here at f of 0. So we see that this function, when x is 0, is crossing the y-axis at 150. And we see that over here at -10, we're at approximately 7. At -5, we're at approximately 33. At +5, we're at 672.61, maybe way up here. And then at +10, way up here at 3,000. So you can see that exponential growth in the function. Let's pretend I hit that as it rises dramatically and quickly over those inputs. -5, -10. I hope that helps.